Hello guys, my voice is audible to you?
Yes, sir.
Okay. So in the last lecture, we saw the minimum distance problem, and we calculated the time taken to time after which the separation will be minimum. We also saw the collision problems, like when we have two particles moving, and the question was after what time they will collide, and what will be the condition of collision. So we saw that the collision is only possible if the relative velocity of any one of the particle, is along the line joining the particles, right? That was the condition we realized, isn't it?
Yes, sir.
So if we have two particles in, and if one is observing two or two is observing one, if the resultant, if the velocity of two with one is towards one, it will hit it. Or if the velocity of one with respect to two is towards two, it will hit it. So this is the condition for hitting. And this is the position vector of two with one. And this is the position vector of one with two. And we got the relation that V12 vector is parallel to R21 vector and vice versa, you can say. So you got the relation V1 minus V2 upon its modulus equals to R2 minus R1 upon its modulus. So if two vectors are parallel, then their unit vector must be equal. So that was the theory from vector. If two vectors okay. So this is what we did, and we solved some question. So okay, I think those who were absent in the last lecture, did you watch the lecture?
Yes, sir.
Good,
Yes, sir.
good, very good. So I realized that okay, and the understanding level was not sufficient. So let me, give you the same problem, and you all can solve with your own way of solving. So if this is the question given to you. Find the time after which both particles will collide. So solve once again, just like a revision. Tell me the answer. And those who are not getting what is this problem at all can solve this question. Try to first understand the basic. Find V relative. That's it. Solve the basic one. Let's see if you really understand the concept of relative motion. So are you all able to draw the vector diagram of a relative motion like a V21 or V12? Because that is the first skill you must have. Then, Harry Siddhant.
Yes, sir.
So what is the time here?
H
H by
V2 square minus V1 square.
root of it square.
Correct. What is the V relative here? What is V relative here? Can you draw the diagram of V12? First, you need to learn to draw the vector diagram if you really want to master the relative motion. So V12 means a velocity of 1, which means add the first vector and the negative of second vector. And you know how to add. You need to add tail to tail. So just join the vector tail to tail. So V1 is shown to you. So how the V1, V2 negative will be looking like. So V2 negative will be like this. Right? And if you join them tail to tail, it will look like this. So V2 is 60 degree from which this line. And so this is V1. So V2 will be minus, we have to add the minus V2, which means we have to reverse and add. And then join tail to tail. It will look like this, because this is 30 degree. So this is the V2 minus V1 diagram. And the resultant of these two vector will be the answer, which we can find easily because this is 6, this is 30, this is 30. So the V relative mod will be how much? Under root of A square plus B square plus 2AB into cos 30, isn't it? So this turns out to be how much? 15 square plus. So 2 into 15 to cos 30 root 3 by 2. If this is your answer, you got the right answer. So are you guys able to draw the diagram first? Tell me. Yes or no?
Yes, sir.
Yes, sir.
So how many of you are able to draw this? Raise your hand. Okay. Manav, you can't draw the diagram.
Yes, sir.
Can you draw the diagram of V2 minus V1? Given two vector, can you draw the diagram of the relative velocity?
Yeah.
Given the velocity, can you draw the relative velocity vector diagram?
Yeah.
Okay. Okay. So this is equilateral triangle, okay? Particle 1 is here, 2 is here, 3 is here. So 1 is moving with velocity v, 2 like this, and 3 like this. Tell me what is V12. First, draw the V12 and tell me the modulus. Draw the V12 and tell me the mod of this. Then, so V12 means what? V1 minus V2. So what you need to do is add the first vector and the reverse of second vector. And how we add it? So you can join the two vectors tail to tail. So first vector is you can do like this. And second, you have to reverse first. This is also V, this angle is 60 degree. So because the vector is equal and angle is 60. So what will be the resultant of these two? The resultant of these two will be, tell me guys. What will be the resultant of these two? Tell me. So it's very simple because it's a symmetrical vector, equal vector. So a resultant must be the angle bisector. So take the component of each vector along this angle bisector and add them together. That's it. You can add as 2v cos 30. This is v relative of the 1 and 2, which is root 3v. Even if you want to do by the formula v relative using vector formula, you can add a square plus b square plus 2ab cos 60. cos 60 is half. So whenever you see the symmetry, you can always take the bisector as the direction of resultant and just resolve the velocity in the direction and add them at the component if it is same direction, or subtract. Is this clear?
Yes, sir.
So this is the first thing. Okay, if you want to understand relative motion, first you try to draw the diagrams and see how you are going to find the relative value of any two vectors. Okay. So if I give you maybe a hexagon. Okay, find these answers. Tell me the answer. Question is clear?
Yes.
Solve this. So now we have 6 particles. I think 3, 5 is not required, so you can do 3, 6. Because 6, 2 and 3, 5 are same. So that's why I have changed it. Then Siddhant,
It's almost done.
Harry,
Yes, sir. Doing just.
Okay, done. I hope so. Okay, so for 1 and 2, so you can see 1 and 2, what is the angle? So you can just reverse it, no? So can see 1 and 2 is exactly the
So it will
reverse
be
of.
150, no?
So this angle is how much? 120, no?
120.
Right? This is 120. So V and 2, so this is 1 and 2. So V12 will be how much? V square 4V square plus 2AB, which is 4V square cos 120 is how much? Minus half. So 2 plus 46. Correct? And V26. So V26 is again very simple. It is 6V and this is 2V. And the angle is 60 degrees, right? So what I've done is I've taken the 2V in the downward direction. I have attached it here simply because you have to add in the reverse direction. So that's done. Understood? So the answer is how
Yes,
much? 4V square 36V square plus 2, 6, 2, 12, 12, and cos 60 is half, so that's 12. So 48 and 52. Yes. And then last is 36. They are anti-parallel, right? Do you realize this? They are exactly opposite of each other. So the relative will be how much? Just add them together. So now tell me, is your answer matching? All three?
Yes, sir. All three matching.
Siddhant?
sir, I messed up the angles. Otherwise, I would have got.
Prashansa?
So only the last one I didn't get. The first two it's matching.
The last one is the simplest one. You can see 6V and 3V are opposite.
Yeah, that didn't strike.
So one should be familiar with the regular polygon always, because the polygon is the, you can say, heart and soul of physics numerical. So you will come across polygon at least 10 times in the entire physics over the course of 2 years. So imagine if you have a n-sided regular polygon. N-sided regular polygon. So let's see how you understand this. So I'm not showing the other part. I'm just showing the only one side. This is the only one side, and a polygon will have center. So n is given variable. Find a v relative. Tell me what is the answer for these two particles. Tell me the answer. I'm not putting arrow, it means I'm asking for the magnitude only. That's it.
Done, sir.
Tell me the answer.
2v cos 180 by n.
2v cos
180 by n.
180 by n. Yeah, so you should write pi by n. Don't write like this. Always write pi by n. All right. So this angle is how much? In a regular polygon of n side, the total angle is 2 pi. So each angle will be how much?
2 pi by n.
2 pi by n. Because the total angle is 2 pi, which is subtended by the n side. So each side will subtend nth part, right? And in any polygon, this angle will be how much? Same as that angle, isn't it? Maybe you can't realize this. So the polygon, the exterior angle of a polygon is same as the angle subtended by the each side, isn't it? So the answer is simple. We have one V like this. And other V, I can just reverse it. I can do anyway, because what we are finding is the relative. And this angle is, so this will be how much? Pi minus 2 pi by n. So the V relative will be, it's a bisector because it's a V and V are same. So the resultant is going to be bisector of these two angles, this angle. So you can do at one go without using the formula. And how much is that? 2V cos half of the angle. So 2V cos pi by 2 minus pi by n. What is pi by 2 minus theta? So answer is sin theta. So answer is 2V sin pi by n. Is this clear? Understood?
Yes.
So why didn't you reverse the second one?
Pardon?
Why didn't you reverse the second one?
But that is the definition of a relative velocity. What is the meaning of a relative? I have explained many times. You can see here. Look at this. So every time you want to find the relative, you have to reverse the other one and then add the tail to tail. That's the meaning of V1 minus V2. Okay.
Okay.
So relative means what? V12 means V1 minus V2 in vector form. And what is the meaning of a negative of a vector? A vector with same magnitude and opposite direction. I hope this is clear to all of you. Is this clear? Siddhant, Harry, Prashansa.
Yes, sir.
See, without drawing the vector diagram, do not expect that you will learn anything in this chapter, relative motion. So vector diagram is must. You must know how to draw it. Understood? Okay, so this is the enough practice, I think. Maybe I can give you one last question. So on a circle, we have two particles. Find V relative of 1 and 2. See, this is the question which should have taken only 30 seconds. If I'm spending
sir.
1 minute, then it's really bad. How much is the answer?
Sir, 2v cos of pi by 4 plus theta by 4.
Wrong. What is the angle between these two vectors? Tell me. What is the angle between these two vectors? We have done this in vector. Don't say we don't know. If every chapter which you have finished, if you're forgetting everything about the chapter, it means the way you study is questionable. You're not supposed to study this way, that you study for one day, then forget next day. The entire process itself is wrong then. What is the angle between these two tangents? This is 90, this is 90. This is theta. This is how much?
180 minus theta.
This is how much?
Theta.
So if the angle between two vectors is theta, so what is the relative velocity? So for relative, we have to take the reverse. The value remains same. So we have to find this angle. And then take the resultant of this. How much? 2v sine theta by 2. You can say 2v cos pi minus theta by 2, which is sin theta by 2. It is clear?
Yes, sir.
See, let me tell you, let me in fact not tell, let me warn you. Make sure that the way you study is concrete enough to retain for long term. Not something which you learn in one day and then forget in the next year. Do not prepare your, JEE the way you prepare the boards examination. So many parents and students come to me and say, okay, in boards, my son, my daughter studied for only 2 months and got very good 95% marks, 98% marks, 99% marks. These marks are like nothing. It means nothing for anyone in the world. Okay. So you study in a different way. Study in a way which can let you retain things. Learn the fundamentals so that you can derive things as and when required. And even though you don't remember any formula, you can reproduce the ideas. Till you don't realize the topic, the concept, keep on studying the same topic again and again. J Advanced is a different preparation. It never demands that you should be master of all chapters. But it certainly demands that you must be master of topics which you have studied. And that is more than sufficient to get into IIT. So the journey of IIT is quite different compared to other journey. Okay, so the relative motion is clear.
So I had a doubt in this question.
Yeah, tell me.
So can we solve this using the components of the velocity?
Yeah, of course we can solve. Why not?
Because I was getting the answer in I cap and J cap form.
That's totally okay. See, you can choose whatever method, component method, but the vector method is the primary goal, because any challenging question will, if you solve by the component, it may take a lot of time. Okay. So you can resolve, you can express each vector into I cap, J cap, and then subtract and then take the modulus. So that is also done. Okay. So for example, let me show you the simple question. A simple case scenario. Let's say if we have a vector v like this, if we have vector v like this is theta. So to convert this into I cap, J cap, we need to choose some coordinate system. So let's say call this is the x-axis, y-axis. So the next step is write a v1 vector. So we can write vi cap. Fair enough. Write v2 vector. So this is v cos theta I cap plus v sin theta j cap. Then either you can find v1 minus v2 or v2 minus v1, doesn't matter. So find v1 minus v2. So let's say v1 2 vector, we can add v1 vector minus v2 vector. So vi cap minus so vi cap minus v cos theta I cap plus v sin theta j cap. Then you can take the I cap together. And then j cap together. And the moment you get a vector in I and j, then you can take the modulus. And the formula is I cap coefficient whole square and j coefficient whole square. And if you solve it, you will get 2 1 minus cos theta. If you solve it further, this will become 2 sin square theta by 2, which will give you answer 2v sin. Now tell me these many steps and only this step. Do you realize the difference? How fast we can do it?
Yes, sir.
So component method is always there. You can always express things in I, J, K, and then take the difference, whatever you want. But you really want to master physics, because in the long term, this kind of component is very trivial. I mean, you're going to get it at least 10 times, 20 times, or maybe more than that in different chapters. So vector way of doing things is always like a very elitist way of doing questions. A very simple way of doing questions. And not only that, if you are good with vector, not only physics, the entire physics, it will benefit you the entire physics. It will also benefit you hugely in the chapter of mathematics. So chapters like vector is not only vector where we use, chapters like complex number is comprehensively used. Even in chapter of coordinate geometry, people use vector notation to get it done easily. So the consequence is tremendous. You're learning at one place, but as you grow in this course of preparation of JEE, you will realize the implication. So it makes life really easier. See, in the beginning, everything is difficult because you want to, attach or add to your, existing knowledge deposit or skill, whatever. It will only benefit you in the long run. So you have to accept new things. If you are learning something new which is slightly difficult, it means it is slightly more useful. So take it that way. Take it in a very positive spirit that you want to learn something and you want to implement something. Do not continue with your comfort. The beginning of preparation should be out of comfort. If you want to remain in your comfort zone and still trying to prepare for the JEE, it is like you are fooling yourself. Okay. So you may fool for a few months, but eventually you will realize that, okay, it's too late now, then what to do now? then all the panic will, button will depressed, and things will go haywire. So that's why I'm saying stick to the the right way of learning, and be it any topic. Vector I taught in such a detail, like almost 10 to 12 lectures of vector, not for this day. Okay. So I hope this is clear. Any doubt in the relative motion of two particles? How to write V relative? Tell me.
No doubts.
No. So those who are solving this question. So if you take this is one particle, this is two. So writing V21 will be what? Or V12? So V12 means what? V1 minus V2. 2 is the observer. So 1 will get a 2 like this. Or 2 will get 1 like this. Do you realize this?
Yes,
The moment you change the frame, things will be like this. And then we have to just think of the component of these two vectors. So there is a thumb rule. There is a thumb rule. What is the thumb rule? If I tell you, where is something very simple. Even without going to vector, you can think this way. Right condition for collision of two particles moving with uniform velocity, as shown in figure. That's very simple. You know the particles 1 and 2. What relation of V1, V2, alpha, beta, let's call beta. V1, V2, alpha, beta, which will make sure that they will collide. Tell me, everyone. Time taken to solve this question is only 1 minute. I'm giving you 2 minutes. Okay. What is the answer, Harry? Tell me.
Sir, V1 sin alpha equals to V2 sin beta.
Very good. You can choose anyone as the observer, then what will happen? So what you are supposed to do is resolve it. So V1 cos alpha. So if you resolve the velocity this way, it will add up. And this way, V2 sin beta and V1. So what we do is we resolve the velocity along the line joining the particles and perpendicular. And we want the net should be along the line of joining the particle, which is only possible if the perpendicular component cancels out each other, isn't it? And for perpendicular component to cancel out each other, they must be equal in value. Yes or no? Tell me, guys.
Yes.
Do you realize this? Everyone? Do you realize this?
So can you explain why it should cancel out?
If it will not cancel, then it will have a net component in upward direction or downward direction, right? So whenever
Yeah.
you have two component, it will go this way, na? Isn't it?
Yes, sir.
So if you want that it should go only this way or only this way, then other component must be 0.
Yeah.
Simple rule is to go in one particular direction, the perpendicular component to that direction must be cancelling out each other. That's simple rule. Understood?
Yes, sir.
So that is why the V1 sin alpha equals to V2 sin beta is the must condition to go that way. And that is why in this question also we have done the same in the last lecture. So if you take this one of the diagram, I want this particle to go this way, which means it is only possible when the perpendicular component must be cancelling out each other, isn't it? So unless V1 is not equals to V2 sin theta, it won't be possible. It's like tug of war, these two will cancel out, and then that's why we will go this way. Because the resultant left will be this one only. Understood?
Yes, sir.
The other way of thinking is you can draw the parallelogram. And the diagonal of this parallelogram must be in this line. Then only it will go this way. We want the resultant to be in this direction. Resultant in this direction, it means all the other component is cancelling out each other. Which component? The perpendicular component is cancelling out each other. Now, what will happen if you don't? If they will not cancel, then they will go away from this path. It will deviate from the path. Understood?
Yes, sir.
So this is the most important concept. Clear? So if you know that a particle is supposed to move in a particular direction, then the resultant component of that particle normal to that direction must be 0. Okay. So this will be useful in solving a variety of questions. So now we are going to do the typical examples. So let's start with the Rain Man problem. So we'll take a very ideal situation of the rain in a mathematical rain. The raindrops will fall in one particular direction. It will not move here and there. The air will not disturb it randomly. So we will have different direction of motion of the raindrops under gravity. So let me draw some rain. First cloud. So this is your cloud and this is the ground. So ideally, if there is no wind, these raindrops will fall exactly vertically downward, right? Now you may think that under gravity it will accelerate, but the fact is, in reality, the air drag will not let it accelerate forever. It will attain some velocity and will fall down on the earth. We are going to assume raindrops to be moving with constant velocity. So raindrop has come down to the earth. And we define something called VR. VR means velocity of rain with respect to ground or earth or whatever. So we'll take the second scenario. So now what we do is we have a very fixed direction of wind flow. So as I said, nothing will be random here. So let's call this is the velocity of wind. And the moment you bring the wind into picture, the rain, the same rain, will fall on the ground, but will it flow vertically downward or at some angle? What do you think?
At an angle.
So will it flow like this, or like this?
Second one.
Second. Something like this, right? But still it will fall with constant velocity. So if you see the VW, so you see when things are continuous, it's very difficult for many students to solve question in which instead of particle we suddenly get the rain, because you don't realize that rain is also collection of particle. Okay. So to deal with such question where you don't see a very discrete particle, rather you see a continuous flow of something, you can take a part of it. You can take a one drop. Mentally, you can choose one drop, and then you can analyze the motion. Okay. So if I just choose one drop of the raindrop, let me keep the color same. So it will have its own velocity because of the vertical motion, which was VR, it used to, and the wind will give a thrust. Okay, it will push it towards the right, and wind will try to give you a velocity. Let's call V delta. And the way you are moving is the resultant again. It's a resultant of these two velocity. So this is the resultant of these two velocity with which you are now moving. That's called VR dash. So VR dash is the resultant of VW and VR. Can you tell me what is VR dash, by the way? It is also velocity of rain in the ground frame. Nothing has changed. The wind has given one extra velocity towards right. Isn't it? So tell me, guys, what will be the VR dash now? VR dash is a resultant of what? VW and VR? Yes or no?
Yes, sir.
So what will be VR dash? Tell me.
VR vector plus VW vector.
So what is the numerical value? The magnitude part. So that's correct. That what you said is correct. That VR is VR vector plus VW vector. And what is the angle between these two vectors?
90 degrees.
So the VR dash value is how much? It is under root of?
VR square plus VW.
It is simple Pythagoras because these are mutually perpendicular components. Do you realize this? Yes or no? Tell me, guys, is this clear? Yes or no?
Yes, sir.
Yes. sure.
Any doubt in this? Anyone? Any doubt? So far, no doubt. Okay. But we are going to study something called rain man problem. So where is man? Okay, I need to bring the man actually. Okay, let's go to back page. So the moment a man, let's say a man is walking. So I'll also mention what is VM. So the way man will see the drops coming will be same as the ground frame observer, or will it change? The motion of raindrops as seen by the man will be different or same?
Different.
Different, because the man itself is in motion, isn't it? The man itself is in motion. Do you realize this?
Yes, sir.
So we can get both the questions, I mean, into picture. So I'll just show you the simplest question. So imagine you can always replace the raindrop with a single drop, and you can assign the velocity to this particle. So you can think this is a particle which is moving down, let's say with velocity VR. So this is the, let's say, example 1. Okay. And here is the man. So the raindrop is exactly moving downward, vertically downward, and the man is walking horizontally. Okay. So how the man is walking? Horizontally. So now this is the particle 2, you can think. This is the particle 1. What I want is, so it will have velocity Vm. So you can draw a big line representing Vm. So I'm looking for VRM in vector form. What is VRM? Velocity of what?
Of rain with respect to man.
So you can say rain means raindrop with respect to so here man is the observer. So what is the object? What is getting observed here? What you are observing here?
Raindrop.
Raindrops, right? So you are trying to observe the raindrops and you are also moving. So if you want to plot the graph, VRM graph, How it would look like the VRM? So by definition, VRM means VR minus VM, isn't it? And if you look carefully, it is VR. So don't disturb the VR, but add minus VM, isn't it? Hmm? Is this clear?
Yes, sir.
So if you know the direction of VR, if you know the direction of VM, then it is very easy to draw the direction of VRM. Just to draw two vectors and add them together. So what you can do is you can keep the VR as such. See, VR is not disturbed. And what we are adding here? Minus VM. What does it mean? So which
Towards
kind of
the
vector I need to add? Tell me. Yeah. Go
VM
ahead.
towards the left.
Very good. So I can add the value as VM only. Numerically, it's the same, no? Lengthwise, it's same. The vector length will be VM, isn't it?
Yes, sir.
So the resultant of these two vectors will give you what? Resultant of these two vectors will give you what?
VR.
VRM. So this is the direction of VRM. So the raindrop will appear to be moving this way. And we generally take the angle with vertical. Let's call theta. So can we write tan theta equals to VM upon VR? Can we say? Yes or no?
Yes, sir.
Generally, they ask that how to hold the umbrella to prevent yourself from getting wet. So to prevent yourself from getting wet, your umbrella must be stopping the drop as you perceive it. Okay. So your umbrella should be like this. A small umbrella. Should we keep the umbrella like this? Yes or no? So to prevent yourself from getting wet, how to hold the umbrella? So the axis of umbrella must be opposing the raindrop coming towards you. Do you realize this?
Yes, sir.
And the angle from the vertical will be same what we got here. So this is a typical question that you will come across, that find the orientation of the umbrellas that we must hold to prevent ourselves. So a moving man will never see the rain moving vertical. It is coming at some angle. And the faster you move, the theta will increase or decrease. As man will travel faster and faster, theta will
Increase.
Decrease.
theta will decrease.
Increase.
See, if VM will grow in value, so we have bigger VM, but VR is constant. So the resultant will be like this, no? So theta has increased or decreased, tell me.
Increase.
So as VM will grow in value, what will happen to the angle theta?
It will increase.
It will increase. Do you all realize this?
Yes, sir.
So that's a very typical question. Okay, there are two types of question you will come across. There are two types of question. When you know the direction of these two components, you start this triangle. You use the vector triangle to draw it and you get the answer. But sometimes, in fact, in most of the question, generally, they will mention that. So we know VRM. Sometimes they will give you the direction of VRM. It means they will mention that the man sees the raindrops appear to be falling at this angle. If man is saying something, he must be saying VRM, not VR, isn't it? So any statement by the man will be the relative value. Yes or no?
Yes, sir.
In that case, the diagram will change because they have given this value. So we write VR equals to V man plus VRM. We just add, we don't reverse anything. If they mention that a VRM is like this, let's say I'm saying the man sees the raindrop, the man sees the raindrop falling vertically downward. If man is saying something, I will say this is VRM. And then man is going towards the right. So I will add man like this also. Why? Because here we don't have the negative sign. Okay. So this is another question. And then you have to plot the VR. So now you can get the answer that the VR must be here, isn't it? Do you realize what I'm saying? So by knowing the VM and the VRM, we can also predict the direction of VR. It's clear? Yes or no? Tell me.
Yes, sir.
So I'm going to share a set of questions right now, right away. And you're going to solve it. Rain man problem. Rain. Oh, okay. So in every question, you are supposed to draw the triangle first. Okay. So there are just 7 questions. And the 1 to 7, if you solve it in the increasing order of difficulty, it's easy, then slightly moderate. What I want is that solve each and every question using a vector. Then I'll show you that how to solve without vector, which will be anyway cumbersome. So in this rain man, because 99% students find the rain man very difficult. The answer is simple. They find it difficult because they don't want to understand through vector. And the other way of solving is difficult for this particular topic. So try to understand through vector only. For every question, draw the diagram. Take your time, realize it. It may take some time. That's totally okay. But make sure that at the end of 7th question, you have a fair idea of triangle law of vector addition. Okay. Okay. So all right, go ahead and solve all the same questions. Everyone. So first 3 done, right? Section D is to solve for part 2. Yes, yes. What is D section? Can you tell me just? What is the title of the section D?
So relative motion in rain and wind.
Yeah, you can start from there also, of course. So first 3 is done. Siddhant, Harry.
Sir, I'm third one.
Third one. First 2 is straightforward, right? Nothing is there. And see, north, south, all directions are a horizontal direction. So don't take it vertical. Many students make this mistake. So when you read north, south, it's all horizontal, right? So all directions are parallel to Earth's surface. It's not upward and downward. And rain is falling downward or something like this. If this is north, this is south, this is east. So this is your up and this is your down. So how many of you are taking the north as upward? Huh? Tell me honestly. Anyone? No. No. Very good. So when you go north, you go upward. You go in sky. If you move really north, you can reach the orbit also. That's dangerous. I hope the third is also done. A man is standing on a horizontal road has to hold umbrella. Okay. So a standing man means what? Ground frame or a moving frame?
Ground frame.
Yeah. So it means that is the actual direction of motion of the raindrop. So first two, I hope, I believe that you all have solved. Okay. So question number 53. A man is standing on a horizontal road has to hold his umbrella at 30 to the vertical to keep the rain away. So it means the rain is falling 30 with vertical. This is VR. So you have to draw something like this first of all. And this is the part of learning, that how you start drawing the things. See, north, south, east, west means just horizontal. So no need to worry about north, south. Okay. So whether they are saying north, south, east, west, just think as horizontal. That's it. So you can draw a man like this. See, these diagrams are also very crucial in physics. Producing the characters or the drawing for the given situation makes things really easy for us. So this is the man, let's say. Okay, so when he walks on the road at 10 km/h, he has to hold the umbrella vertically to keep himself dry. Okay. So when you walk, then you have to keep the umbrella vertically. So you know the VR, and you know the VRM when you walk. So that's very interesting here. The VRM by definition is VR minus VM. And in this case, if you look at this scenario, the VM is unknown, whether it's right or left or whatever. Because we know VR, let's say I have drawn the VR, and I know the VRM also. Okay, lovely. So I can add VR equals VM equals to VR minus VRM. Okay. So the rain and minus VRM. How is the VRM, by the way? So this will be slightly difficult. This is easy one. I think I will stick to the same thing. VR equals to VM plus VRM. So I want to produce this VR using these two vectors, the man and the VRM, and I know VRM is given to us. VRM is given to us as vertical, right? This is VRM. Now tell me guys, if I know VRM, to get this VR, how I must walk, left or right?
Right.
Listen to this. I need VR this way. And VR is the summation of VRM and VM. So VRM is downward. How to add to get VR like this?
Left.
It must be left, isn't it? So the man is walking this way. And that is why this is VR. This is V man. And this is given to us how much? 10 km/h. What are they asking? Find the speed of the raindrops with respect to ground. What are they asking? Tell me. Can you tell me what are they asking? They're asking VR, isn't it? Velocity of raindrops with respect to ground. This is VR. Yes or no? Tell me, everyone.
Yes, sir.
So given the angle theta, which is 30 degree, and one of the side which is 10, can you find VR? Which trigonometric relation will give you the answer? Tell me.
Tan theta.
Sine theta.
How to explain this? You have given this, and you want this. Which relation will give you the answer?
Sin theta.
Cos
Sine theta.
Cos theta, sin theta, whatever. So it is sin theta. So sin theta is how much? Opposite upon hypotenuse. It is 1 by 2, 10 by VR. Tell me, guys, is this the answer? 20 kilometer per hour? Just check the answer.
Yes, sir.
Yes, sir.
And the man is going towards the left, as per this diagram. So, yeah, that's it. Similarly, can you apply try the question number 54? Ah, yeah, right. This question in a different sheet. Okay. Just a moment, let me share it. So solve the next one. See, you have to struggle to get this diagram first, and you have to use this relation always. Think about what is given to you. So if you know VRM direction, always use this one. And if you know these two, use this relation. In one case, you have to revert the one of the vector. In other case, you can continue with the same direction. So unless you are not plotting it, the triangle must be completed to get the answer. 54 done. Siddhant, Harry, tell me. So for a man running on a horizontal road at this, rain appears to fall vertically. So he increases his speed to 12 km per hour. Now he finds the rain hitting him at 30 degrees vertical. Find the speed of the raindrops with respect to ground. Okay, so there are two diagrams. Like you have to draw two triangle for two different speed. For one for 8, other for 12. So at 8 you can draw, this is similar, no? At 8 it will be something like this only, isn't it? And that hit, instead of 30 degree, you can choose theta because you don't know, right?
Yes, sir.
Okay. And if you move faster than that, what will happen? The VRM will change. So you have to draw a separate diagram, like maybe on the same scale, at the same place, but another triangle. See if you are able to get that triangle. Let's see. Keep on trying, keep on trying. You will get the answer. Rayman is the most difficult part of this relative motion. The rest is very easy.
So for the 54th one, I'm getting 4 root 3 as the answer.
What is the answer given? You can check
4
the
root
next page.
7.
4, 7. Okay. So let's see. So look at the question number 54. Oh. So a man running on a horizontal road at 8 km per hour, rain appears to fall vertically. Let me tell you something more insight about this event. See, technically, if the rain itself is falling vertically, you won't see vertically if you start moving. What I'm saying is, if the rain itself is vertical, the moment you start walking or moving, the rain will appear like this. Question is saying, no, the rain is falling vertically when I'm moving actually. So that is only possible. Let me tell you when it is possible. Imagine a person is going towards right and the rain is also falling towards right. That's a very simple logic. And this is the rain. Okay. This is some angle theta, which I don't know. And this is the velocity of man. So if the rain is falling vertical, it means the man velocity and the rain will have two components. You can think this way: the rain will have two components. One is VR sine theta, another will be VR cos theta. Why I'm saying this? Let me tell you. So because the rain will have two components, VR sine and VR cos, and the man will also have the horizontal component. If these two components will match each other, then you won't be able to see this component. It means only vertical component will remain. Are you getting my point?
Yes,
What
sir.
I'm saying? The moment your velocity is same as this component in the relative frame, only this will be left out. These two will cancel out. Or if you draw the ABD of the droplet, drop will have two velocity, one down, VR cos, one right, VR sine, and the man left. Unless these two will not cancel, it cannot fall vertically downward, right? So
Got
for
it, sir.
vertically downward, it must be equal to each other. That's why I am saying that this is the scenario. But anyway, this is the thing. But if you want to solve by the vector as we are doing it, and it is about realization. For the first time, you are looking at it the way I'm solving, but next time you can solve on your own. So basically, if the rain is falling this way and you are moving towards the right, then there is a possibility that this component, the VM, which is 8 actually, this VM is 8. This will make this VR because if you read the question, it is saying that okay, when it is 8, it is falling vertically downward. Now, when you make it 12, right? What is the question? If you make it 12, 12 means what? The same arrow will grow like this, isn't it? So as you make the VM bigger, the tip of the arrow will go somewhere here. And this is now 4 extra. This is 8, this is 4. And what it is being said in the question that the raindrops appear to be falling at what angle?
30-degree with the vertical.
Exactly. Now you know this is 30 degree. Understood? This is 30 degree. So this theta, this VR, this 8, this 4, this 30. Can you do the calculation to get VR? How you are going to do this? So you can take the vertical line as something, this is VR, it's given to us in the initial case. So I will remove this VR just a minute because there are too many VR. The first vertical line is the VRM in the first case. The second red line is the VRM dash in the second case. Okay. So in the triangle, I can add tan of theta equals to 8 by VRM, or not VRM, I'll write as VR cos theta because VR is fixed. As you walk, what remain constant is the velocity of rain. Because velocity of rain will never change because you run fast or slow or whatever you do, whether you dance, doesn't matter. So tan of theta is 8 upon VR cos theta. Okay, that's easy. What about the tan 30? Yeah, that's interesting. So why I'm writing this? So sine theta is how much? 8 by VR. Question 1. Okay. So VR sine theta, we are getting how much? 8. In the second case scenario, the tan 30 will give you some answer. What is tan 30? 4 upon the vertical line, which is VR cos theta. So VR cos theta, you are going to get how much? 4 by tan 30. I hope you know the tan 30 value. It's 1 by root 3. So I got VR sin theta, which is 8. I got VR cos theta, which is 4 root 3. But they're asking what is VR. So squaring and adding equation 1. Squaring and adding equation 1 to what do you get? VR square equals to 8 is sorry 8 square plus 4 root 3 whole square. 64 plus how much? 48. I think 112. What is VR then? So how much is this? 112. It's a 4 root 7.
Yes, sir. 4 root 7.
And that's why you're not
Understood,
getting answer. Okay. So the thing is, yeah, it's not very easy. This was the most challenging one, but now you can solve this 55 and 56 and 57. Try this out.
So can you explain the first part of the diagram?
Yeah. So the first part says that the rain appears to be falling vertically downward when you walk at 8 kilometer or whatever, 8 meter per second, 8 kilometer per hour, whatever. Okay. Now, see, the vertical is only possible, as I said, when the rain will have horizontal component matching the horizontal component of man, then only rain appears vertically downward. Because if this will be matching, you won't be able to see the horizontal component. So what will appear is only vertical component. So that's why I chose the man going towards the right. Okay. And then the VR must be having forward slant. Then only you can see it's moving vertically downward. You can realize by drawing the triangle. See the rain. If I assume rain this way, you have to take all the cases. Take all the cases and okay, I'll do it for you guys. Take all the scenario and try to draw the diagram in every scenario. Then only you can realize what is happening. So I could have given all the diagram in the beginning, but I thought first you practice, then I'll give you. So imagine a 3 cases situation. The rain is falling this way, rain is falling this way, rain is falling this way. And I'm taking the motion of the man always towards the right. That's easy way because I can deal with each situation. Okay. Now tell me, in every case, I want to draw the VRM. Okay. So VRM, if you remember, VRM by definition is what? VR minus VM. So this is VR. This is VR. This is VR. Practice all these things. Minus VM means what? Left, left, left. Okay. So this is minus VM. Try to understand what I'm doing here. So the resultant of these two will give you VRM. So in this case, the VRM is going to be this only, right? Try to understand. In this case, the VRM is going to be like this, yes or no?
So we are assuming that the man is walking towards the right, right?
Yeah. You have to assume something, then only you can draw, right? So choose either right or left. If you can, if you want to draw, think left, keep it left. Okay. Look at the second scenario carefully. In this case, the resultant of these two vectors can be anywhere. No? I have no idea. It could be like this. It could be like this also. But it will be somewhere in between, right? So the resultant is going to be from here till here, anywhere. Anywhere from here. So that the possibility of vertical is in this case. In this case, we can have this way also. Yes or no? Tell me.
Yes.
Can we have the VRM like this in this case? Okay. Now, if I make it the pink color line bigger, what will happen? You know? If you make the pink bigger, it will shift towards left like this. As the pink line, the VM will grow in value. It will go from, if VM is 0, it will like this. VM bigger, vertical, then bigger, like this. Okay, so there is a possibility of this also. There is a possibility of so there are many possibilities. So the resultant could be like this, it could be like this. So there are all three possibilities of a resultant. In the last scenario, look at this carefully. The resultant of these two is only possible in this between these two lines. So it is somewhere only here. So can we get the vertical direction of VRM in the third case? Is it possible? Tell me, guys.
No, sir.
So whenever the question comes, because okay, we have done this. Let's see if I have done this before, we can understand right away. Okay, this is the correct diagram to proceed with. But as a beginner, I mean, see, even for every student, including me, when I was preparing for like you, we also found this topic particularly difficult. Whenever it was a challenging question, it was really difficult. But with some idea, some notion, you can crack it. If you're able to draw the correct diagram of triangle, it becomes really easy. And over the time, I realized that okay, I you should teach in a different way earlier. Like in the beginning of my career, I was teaching like component, but I found that component is even more confusing for most of the students. So they used to complain so that in the component method, I'm getting stuck. I'm not able to solve question or equation. So over time, I would say, okay, I realized that okay, vector is the right way to go for VRM problem, the Riemann problem. So you have to develop the idea, okay, as per the VRM. Think about it, draw the diagram, something more suitable diagram. Because once you draw the triangle, it is the triangle which you need to solve, which you can solve by the sine, cos, and whatever. So it's really easy. Understood? So you got some idea how to proceed.
Yes, sir.
And there are two things. See, if you know the if you know the VR, VM, then you can get VRM like this. If you know the VARM and VM, so I've told you plot either these two diagrams. So draw triangle. This is simply there are only two choices. Either you plot this triangle or plot this triangle and see which one is convenient to you. That's it. So as a beginner, just keep on plotting till you get it right. So it will take some time before you can master it. And choose the direction of man always right. That's easy for you. I'm giving you. Always choose right and draw the diagram accordingly. And see which diagram is giving you meaningful answer. So do it this. Solve 55. Got the answer, Harry?
Yes, sir, solving.
Siddhant?
Yes, I got it.
Done.
Okay. Got the answer?
Yes.
Very good. Solve the next one. I think 55 is replication of 54 only. Somewhat similar.
So can you please go to the previous one?
Okay. You can solve this mentally without solving. But for that, you need to draw the triangle in your mind. And when you will draw the triangle, you see it's a equilateral triangle. Are you done with the remaining?
Sir, solving 56.
Yes, sir. Tell me, you were saying something.
Done, sir. Both.
All done? Up to 7?
Yes, sir.
Okay. Siddhant, you
Yes, sir,
have any
same.
doubt?
No, sir, done.
Done. Prashantha, tell me.
Sir, I'm on 57.
Very good. Very good. So what you will do is you will revise all these questions at least twice, just to get a grasp on the entire process. All right. So I will prefer this triangle method. Now we can go to the next concept actually. So in a relative motion, we have done 2 parts. Now we are going into the third part called the river boat problem. And before we solve this question, let's try to understand what exactly happens in case of river. In case of river, the surface of the river is in a moving state. Okay. So surface of a river in a moving state. So it means you can think as a cardboard which is floating. So if you put a wooden log onto the surface of a river, it will move with the velocity exactly same as the velocity of the surface of river. Okay. So that we call flow velocity. So there's a term called velocity of a river, or you can also call flow velocity. So in case of a river problem, you can think this is a river. In our case, the river will have finite width all the time. It will not change. So generally we call D as the width of the river. Okay. And the surface you can think as a rigid surface. You can always replace a river by a fixed a rigid surface, which is moving with the speed similar to the flow velocity of the river. So river is having some its own velocity called the flow velocity, as I said. And this velocity we call u, and u is called the velocity of a river with respect to, you can say, ground, you can say the bank or whatever. So u is called velocity of river. So we don't take a vr or b, something like this. Or we stick to the uv notation because that's convenient and writing wise it's easy. So velocity of a river is also called the flow velocity. And we know that in the direction of flow, we call downstream, and against we call upstream. So I think you are aware of the term downstream and upstream. Okay. So I'll just mention this quickly. So the right arrow we can call which stream, down or up?
Down.
This is downstream, and this is upstream. So you can imagine like in a moving train. Okay, if you have taken a journey by a train, the way you walk inside the train, does it depend on how fast the train is moving, or is it independent motion? So let's say you're in a train, you just walk from your berth to the nearest pantry to have some food. While you walk, does it affect, does it matter that how fast the train is moving? Does it really matter when you walk?
No, sir.
Everyone tell me. Does it really matter when you walk? How fast the train is moving, or you can walk independent of the speed of train?
Yes, sir.
So your motion is independent of what? Motion of train, isn't it? Tell me yes or no.
Yes, sir.
Now, similarly, when you try to swim, or when a boat or a steamer will try to propel on water surface, no matter how fast the water surface, your ability to swim remain unchanged. Okay. So when you go from your berth in a train towards a pantry, in ground frame you have traveled a lot actually, because while going from your berth to the pantry, the train has traveled a lot ahead. But those things we are not able to see, because what we see is relative motion. We don't see the ground frame motion, isn't it? So your motion ability is relative or ground frame? So when you walk inside the train, is it ground frame velocity or it's a motion with respect to train actually? Tell me.
Motion
you're-
with respect to train.
Yeah, when you're moving inside the train, so your velocity, the speed with which you're running or walking, it is a relative velocity or it's an absolute velocity? Tell me, guys.
Relative.
It is always relative. It is not absolute. It is not in ground form. It is with respect to the surface of train on which you're walking. Similarly, when you move on a swim, or you can say, no, you cannot walk, so you can swim, or you can propel a steamer, a boat, or kayaking. In that case, your motion is with respect to the water surface, not ground. Okay. So every moving object will have the ability to swim or move with respect to water surface, not ground frame. And here the water surface itself is in motion. It is not at rest. So we call it upstream and we call it downstream. Okay. You can move the way you want. So we use the term V, which is called velocity of man or swimmer or boat or whatever. So velocity of swimmer, boat, or whatever, with respect to, now this is something crucial. So I'll add the exact thing with respect to still water. And that is the source of confusion. So as a beginner, when we read this letter, this sentence, we get confused that velocity of swimmer or boat with respect to still water means what? Whether the water is still or moving, it is with respect to water surface. So V represents the ability of the swimmer to swim with respect to water surface. Understood? So still water means when water is still, you can see your ability. And luckily that ability will be same as the ground frame. But the moment you start, the water start moving, okay, your ability remains same. So V means your ability to move relative to the water remains same. That's why it is actually a relative velocity. It is not the ground frame velocity. So there is a very common confusion that the V represents velocity of the swimmer with respect to ground frame or with respect to water surface. So whether this is a relative or it's absolute. So the answer is V represents a relative velocity of swimmer with respect to water surface. I hope this is clear. So what is V representing here? How fast you can swim relative to the water. It is like how fast you can walk relative to the train surface. Does it mean that that will be your speed in the ground frame also? So if you can run inside a train with a speed of, let's say, 5 meters per second, and if a train is going with a speed of 20 meters per second, and you also run in the direction similar to the direction of train, how fast are you moving with respect to ground? Tell me. Am I audible, guys?
Yes.
Yes.
So this is the train. You are running with respect to the train at 5 meters per second, and train is running in the ground frame with let's say 10 meters per second. So how fast you are running in the ground frame?
15 meters.
15.
That's common sense, because even if you don't move, you will move with 10. The 5 is additional, extra value, isn't it? So in total, you're moving at 15 meters per second, because 5 is not the ground frame answer. 5 is given as velocity in the frame of train itself. Okay. So to understand the question of boat, a river boat, or the bird and wind problem. So a bird will fly with respect to wind. A boat will, a man will swim with respect to water. Okay. So whether you're flying or you're swimming, you always fly or swim with respect to medium, not ground. Because swimming is an exercise which is happening with respect to the water. A bird will fly with respect to the air. So you push the surrounding air and then you move. So if the wind also starts, like if there's a wind, which means if the air starts moving, the bird will still fly with the same speed with respect to wind, and the wind speed will become additional value. Similarly, when you walk inside a train, your walk is independent and the train will give you additional value. So when you swim, then that is your ability, and the water will give you additional value. So always remember this way, that the velocity of the water or the river or the flow is the additional velocity which you get beyond your ability. So V represents the ability of the swimmer or boat or whatever. So basically, if you want to write mathematically, you can write a velocity of let's say man with respect to swimmer, river, what I'm saying, with respect to river. So by definition, this becomes V man minus V river. So generally, we are looking for a velocity of man in the ground frame or swimmer in the ground frame. So this will become V here. And this is called the ability part. This is your ability. This is your ability to walk or run or swim or fly with respect to medium. So this is the ground frame. This is always relative. Okay. I hope this is clear in the vector way. So if you go downstream, if V is downstream, what will be your velocity in the ground frame? Okay, V remains same in every direction. Do you remember this? A man can swim in any direction with the same speed. But river will give you additional value. Okay. So that's why if you're going towards, if you're going downstream, so your velocity is V and a river will give you additionally U. So what is the net velocity? So
V
velocity of
plus U.
the swimmer will be, in case of upstream, so let's say you're trying to move this way, but a river will give you, I'm assuming that you can move faster than river as of now. So you will go upstream or downstream. So you will go upstream. What will your net velocity? So net upstream velocity is how much? V minus U. Yes or no? Tell me.
Yes, sir.
I think this is simple enough. So we'll solve the first question, which is very simple. So we'll solve one dimensional question first, then we'll solve the two-dimensional question in the next lecture. So in next lecture, we should be able to finish the chapter completely. And then we'll go for the laws of motion, brand new chapter. So, okay, then now this is the question. So there are some terminology which will come across very much new to you. So don't worry. In river or ocean, we have something called have you heard this name? Boy. It's not boy, it's boy. It has come from the word buoyancy, right? So these are called floating object. You know what is its role? It acts as a milestone, some sort of idea that okay, you're close to the shore, and every big cruise which comes to any port, they do not cross certain region, because if they come very close to the shore, it will sink because the water level is less. So they remain very far away from the shore, that you must have seen, and then a small boat will come closer to the shore. Okay, so the big cruise will be really far away, and they make sure that there is sufficient depth of water to hold the cruise. So we have the floating object called buoy. It will be like a fixed object. So even there is a flow of river, the buoy will not move. Understood? Because it will have some chain system also hanging. So it will prevent it from going right or left. So a very heavy chain is suspended. So as the you can see the waves will hit the buoy, it will go right or left, but the chain will make sure it's there only. Okay. And now what you do is a person starts swimming. So a person starts swimming with ability V. So V is the ability. V is the velocity with which you can swim with respect to the water surface. But in reality, how fast this guy will move in the ground frame? So in the ground frame, its velocity will be how much? V plus U, isn't it? Tell me, guys. Tell me.
Yes, sir.
So he goes from A to B and then returns back. But while coming back, what will be its velocity? Because the river is going this way. So V is the velocity of the man with respect to the still water. And I have explained that what the meaning of still water doesn't mean ground term. It means that with respect to water surface, it can swim with speed V. That is the meaning. Okay. So it goes from A to B and then returns back. Find the average speed for the round trip journey. Round trip journey. Between two boys. Questions clear? Tell me, guys. Hello, hello, hello.
Yes, sir.
Solve it. So I hope you know the definition of average speed.
So I'm getting the answer as v square minus u square by v.
Correct. I think that should be the answer. So the average speed means total distance traveled upon total time taken. So while going A to B, the time will be how much? Assuming D is the distance. What is the time taken to go from A to B?
d by v plus u.
And while coming back,
d by v minus u.
yeah, so 2 will also come now. Maybe not. Okay. So the answer is 2 upon V minus U, V plus U. So it's 2V. Yeah, correct. So the answer is correct. V square minus U square by V. I hope everyone has got this answer.
Yes, sir.
Yes, sir.
A very simple answer. So do you have time, Siddhant, or you will go for lecture?
Sir, I have lecture.
Yeah, so we can take a break. We need some break also. All right, guys. So what is the time of lecture? 9 o'clock or 9 to 10? 9:15?
Sir, 9 o'clock.
9 o'clock. Okay. So now we are going to do the remaining part. It's a big topic actually. So we learned something great in great detail about the riverboat problem, and we'll solve some of the challenging problem from the old text, and the chapter will be over. Hopefully, by next lecture, maybe 1 hour will be left. So bye guys, take care, and you can start solving the sheet which I have shared. Okay.
So I had a doubt in the 56th question.
56 question, today's question.
Yeah.
Okay.